Controlling LEDs with an Arduino is fun and easy. You can animate your LEDs in an infinite number of ways. Everything is left to your imagination. In this code discovery session, we will look at the schematic for LEDs connections to an Arduino and several useful functions to animate LEDs like blinking LEDs, changing the brightness of LEDs, display random LEDs, chasing LEDs, and many more. So let's get started. First, let's look at the connections between the LEDs and the Arduino. This is my Neutron Star Detector, a kind of sci-fi props inspired by Star Wars. For this build, I use an Arduino Nano, but it will work the same on an Arduino Uno. I have rows of 10 white LEDs all connected to the Nano. The first row of LED is connected to pin 12 and 11. The second row of LEDs is connected to pin 10 and 9. The third row on pin 8 and 7. The fourth row on pin 4 and 3. And the last row of LEDs is connected to pin A0 and A1. That's a lot of connections, but a lot of LEDs leads to a lot of fun. I have two more LEDs, a blue at the bottom and a red at the top. These ones are special because they are connected to PWM pins. This will give us the ability to control the brightness of the LEDs. The blue LED is connected to pin D5, and the red LED is connected to pin D6. Pin D5 and D6 are PWM pins on a Nano. If you have another model of Arduino, check the specifications to locate PWM pins. Here are all the PWM pins that are available on the Nano. Now it's time to play with LEDs and look at some code that you can use in your projects. As you can see, I'm using VS Code for my code editing, but the code I'm going to show you will work just fine without any modifications if you work with the Arduino IDE. And if you're interested in using VS Code in your projects, a link is available in the video description. I have a little tutorial now to set it up for Arduino. And the code I'm going to show you is also available on my website. The link is in the video description. In order to be able to manipulate LEDs in our code, we need to define them first. So we define a variable called, in this case, blue LED that is connected to pin 5 on the Arduino Nano. And we define a red LED that is connected to pin 6 on the Arduino Nano. And if your setup is different, if you have LEDs connected to different pins, just change the number here in your code. So in the code, we will use, instead of using the number 5 and the number 6, we will use the defined variables, blue LED and red LED, so the code is much more readable. If we look at the Neutron Star Detector, all the white LEDs are kind of stick together. So if I want to easily animate them in the code, I have defined an array. And inside the array, I have each pin where a white LED is connected to. You can go back in the video and look at the schematic, and you will see that I have a white LED connected to pin 11, a white LED connected to pin 12, and so on. And the last one is pin A1. And the order inside the array is important because when I do animation inside a loop, I want to be able to go from the bottom row, so the white LEDs at the bottom, to the top row. So the order is important. And here I have a variable that contains how many LEDs I have in the array. In this case, I have 10 LEDs. So in case you don't know, this is the way to calculate the size of any array in C code. In the setup functions, I have an init LEDs function. And it's important before using any LEDs in your code to define the pin where the LED are connected to as an output pin, so you can turn it off or turn it on. using the pin mode instruction. So in that case, for example, the blue LED is connected to pin 5, and I define it as an output using the pin mode instruction. Same thing for the red LED, which is connected to pin 6, defined as an output with the pin mode instruction. For the white LEDs, I use a for loop so that I can go through the array where the pin of the white LEDs are defined. So remember, the white LEDs are connected to pin 11, 12, 10, and so on. So I loop through the array and define each pin of the white LEDs as an output. If I don't do that, I would have to define 10 more pin mode instructions, and for example, say pin 11 is an output, pin 10 is an output, pin 9 is an output, and so on. So I save time by using this array. Let's look at functions that do animation to LEDs. We will start with simple functions, and we will go through more complex functions that do more complex animation to the LEDs. The first one is called write LED. This one just turn on or turn off a LED by specifying its pin number. So it has two parameters. The first one is the pin number where the LED is connected to, and the second is a value. If we want to turn the LED on, we specify high as the second parameter, or if we want to turn it off, we pass low. In that case, we will pass high. I'm going to upload the code to the Neutron Star Detector, and you will see that the first LED at the bottom row will lit up, like so. So remember that the first LED at the bottom row is pin 11. So in order to get that pin number, I have to pass to the write LED function the first pin in the index, which in C code is always at index 0. This is why I use index 0 in the white LEDs array so that it can pass pin number 11. So if we look at the write LED function, it's very simple. We use the digital write function in Arduino to write the value to the pin where the LED is connected to. The next function is called write all white LEDs. So it's acting on all the white LEDs on the device to turn all the white LEDs on by passing high as the parameter, or passing low if we want all the white LEDs to turn off. So let's see the result when we pass high to the function. So it will turn all the white LEDs on the device on, like so. And if we look at the function, again, the function is very simple. We loop through the array of pin numbers for the white LEDs. So we go through pin 11 up to A1. And we reuse the write LED function that we just saw earlier to turn individual LED on or off. So in that case, we're acting on just the white LEDs. The other function is called write all LEDs. So it will be acting on all the LEDs on the Neutron Star Detector. And it will turn on, in that case, all the white LEDs, the blue LED, and the red LED. So let's upload the code to the Neutron Star Detector. And we will see that all the LEDs are lit up, like so. If we look at the function, so the function is very simple. We first called the write all white LEDs first to turn all the white LEDs on because we passed the value I. We look at the top. We pass the value I to turn all the LEDs on. And after that, we use the digital write function on the red LED pin and the blue LED pin to turn them on. The next function is called invert LED. So what the function does is turn the LED on if it's off, or turn it off if it's on. So here we're inverting the state of the red LED. So when we when we upload the code, all the LED are turned off automatically because the microcontroller is resetting. So the red LED will be in the state of off, and it will be turned on. And if we modify the code, let's add a delay of 4 seconds. And let's call the exact same function with the red LED parameter. And you will see now the microcontroller will reset, turn off. So the red LED will be turned on first. And after 4 seconds, it will be turned off. So if we look at the function, so the function is using the digital read function of Arduino to read the state of the pin where the LED is connected to. So if the LED is on, it will turn the LED off. Otherwise, it will turn it on. We're going to look at functions that do more animation to the LEDs. This one is called blink all white LEDs. So what it does is blinking all the white LEDs, and it has two parameters. The first one is the duration of the blinking. In that case, it is 5,000 milliseconds, which is 5 seconds, at a speed of half a second. So if we upload the code, you will see that all the white LEDs will be blinking during 5 seconds at a half a second interval, like this. So if we speed up the blinking, let's say 250 milliseconds, let's upload the code again, and you will see that the blinking of all the white LEDs will be faster. Like this. So if we look at the function, we have a loop for the duration that is passed to the function. And we are doing two things. First of all, we're using the write all white LEDs function by turning on all the white LEDs. We wait by waiting the speed that is passed to the functions. And after the delay, we turn off all the white LEDs by calling the write all white LEDs function. So the loop is using a duration function. So it's kind of a helper function that is defined, if I remember well, at the top of the file. So it's two functions that are helping to execute code for a certain duration in milliseconds. So you init a timer with the duration that is passed to the function, and you're doing a while loop by calling a duration function, and the while loop will end when the duration is expired. The next function is called power up LEDs, and it has no parameters, and it's doing some animations to all the LEDs on the Neutron Star detection device. So let's execute it and see what it does. So you will see that first of all, the blue and the red LED are powered up, and you see the intensity changing. So it's going from low intensity to high intensity. And after that, the white LEDs are turned on from the bottom row to the top row. So if we look at the code, so first of all, we take advantage of the fact that the blue LED and the red LED are connected to PWM pin on the Arduino. So PWM pin, when connected to a LED, gave the capability to change the intensity of the LED. So you can have an intensity from 0 to 255 by using the analog write function of Arduino. So in that case, we go through from 0 to 255. Here you see 256, but we stop when we reach 256. And we write to the blue LED and the red LED the value, which will go from a low intensity to a high intensity. And we do it somewhat fast by applying a delay of 30 milliseconds between each loop. So once the loop is done and the blue and red LED are lit up at high intensity, we're going through the array of white LEDs and we lit them up row by row by using the right LED function to turn on each row of LEDs, 2 at a time, with a delay of 1 second. The next function is doing a power down LEDs. So it's doing the reverse of the power up LEDs. So let's see it in action. So the first thing it will do, it lit up all the LEDs. And you will see that the red and the blue LED are at high intensity and the brightness of both of them are going to a low intensity. And after that, the white LEDs are turned off row by row from top to bottom. Now, if we look at the code, the first thing we do is turn on all the white LEDs and turning on the blue LED and red LED at high intensity, which is done by using the analog write function and passing 255 for high intensity. We wait 2 seconds. After that, we're lowering the brightness of the blue LED and the red LED by using a for loop, which goes from 255 to 0, and we are using the analog write with the same speed as the power up, 30 milliseconds between each loop. We wait 1 second and we power down the white LEDs by looping through the white LEDs array and turn off row by row each LEDs on the device and a delay of 1 second between each row. The next function is called the smooth blink LED function. It has 2 parameters, the LED that we want to blink and the duration of the blinking. And this function blink the LED using the brightness of the LED. So the LED goes from a low brightness to a high brightness and from a high brightness to a low brightness. So let's see it in action. Let's upload the code and you will see that the blue LED here at the bottom will blink using its brightness like this. So for 5 seconds. And if we look at the code is making use of the duration function. So between the while loop, the code will be executed for the duration that we pass to the function. So we change the brightness of the LED by using the analog write function of Arduino. And we use a variable called direction to change the brightness. So from low to high and from high brightness to low, with a delay of 3 milliseconds. So the blinking is fast. And once the function is completed, we turn the LED off. The next function is called display random white LEDs. And it has only one parameter, which is the number of white LEDs that we want to lit up randomly. Let's upload the code. And you will see that on the panel, 5 white LEDs will be lit up randomly, like this. So if we look at the code, inside the code, we make sure first that all the white LEDs are turned off. And we have a loop, a for loop for the number of LEDs that we want to turn on randomly. We use the random function in Arduino, and we pass it the number of white LEDs that we have. And we turn on the LED that has been returned from the random function. In order to make good use of the display random white LEDs, I wrote another function that is called display random white LEDs duration. This one will display random white LEDs, 6 random white LEDs for a duration of 5 seconds at a speed of 400 milliseconds. Let's upload the code and you will see that on the panel, 6 random white LEDs will be turned on for a duration of 5 seconds. And sometimes you see that there is less than 6 LEDs that are lit up. It's because, like in this case, there is only 4 LEDs. It's because the random function is returning the same LED twice, or even it could return it 3 times. So let's look at the code. So again, we're making use of the duration functions. And we're calling the display random white LEDs with the number of LEDs that we want to be randomly lit up. And the speed delay that is specified with the speed parameter. And for example, if we go back to the function call, and let's see, we want it for 10 seconds. And at a faster speed, let's say 200 milliseconds. Let's upload the code again. And you will see that the speed will be much faster. Like this. The next function is called the random white level function. And what it does is turn on the white LEDs from bottom and stopping at the random level and going down again. And the only parameter is the speed of the going up and down. In that case, it's 1 second. So let's upload the code and look at the white LEDs on the panel. Going up, stopping at the third row, and going down. And the third row where it stopped was chosen randomly by the function. And if we go look at it, the first thing we do in the function is choosing the row, the level where it will be stopped randomly. We have a for loop going through the LEDs, turning the white LEDs on, stopping at the level that was chosen randomly. And we have another for loop going into reverse. You see here that the variable is incrementing, and we turn off the white LEDs. Now to improve the random level white LEDs to make it more useful, I wrote another function called random level white LEDs duration. So what it does is lit up the white LEDs randomly from bottom to top for a duration of 6 seconds, in that case at a speed of 400 milliseconds. So let's upload the code. And you will see that it will do its job for 6 seconds. Like so. Let's change the speed. Let's speed it up and having a speed of 100 milliseconds. Let's see. We'll see that the speed of the display will be much faster. And let's try to speed it up again. Let's say 25 milliseconds. And you will see that the animation is much more faster and much more appealing. It's like we're picking some noises or voices in the room. So let's look at the function. So the function is very simple. We have a while loop that is making use of the duration functions. So for the duration of the function, we are calling the random level white LEDs at the speed passed in the parameter. The next function is called shoot white LEDs single. So let's see what it does for 6 seconds. The code is uploading, and take a look at the white LEDs on the panel. So you see the animation. So it goes from right to left and from bottom to top and top to bottom. So basically what we do during the duration of the function is turning on the white LEDs and turning them off in a sequence so that it's displaying an animation. And the last one, it's called shoot white LEDs double. So this time a double row of LEDs will shoot up. Let's upload the code. See what it does for 5 seconds. It's shooting up white LEDs. So let's look at the code. So again, the duration function is used, and we're we're actually turning white LEDs on and turning white LEDs off with 2 for loop for doing the animation. So we've gone through all the functions. You saw that controlling LEDs with an Arduino is easy. All the code you saw is available on my website. The link is in the video description. My hope is that you use and improve the code for your own Arduino projects.